In this example, we're going to take the vector 2, 3 in terms of a standard basis and write it in terms of a different basis. So in terms of our standard basis, 2, 3, we look at a vector I, a unit vector I, and a unit vector j. We go 2 on the x and 3 on the y. So our vector looks like this. So in terms of our standard basis, this is 2i plus 3j. Okay, so in terms of our standard basis, it's 2i, 2j. I, of course, is 1, 0, and j is 0, 1. If we want to write it in terms of a new basis, b1 and b2, well, we have to look at what the vector AB would look like if 2, 3 was written in terms of this basis. So we write 2, 3 is equal to A times 1, negative 1 plus B times 1, 1. So we're looking at the coefficients A and B that break down the vector 2, 3 into components that come from 1, negative 1 and 1, 1. So this is the first way of writing a vector that's in a standard basis in terms of a different basis. I'll show you both methods. Here we've got, if we solve this, we've got 2 is equal to A plus B, and 3 is equal to negative A plus B. And if I add those guys together, I get 5 is equal to 2B, or B is equal to 5 halves. If B is equal to 5 halves and A plus B equals 2, we end up with 2 is equal to A plus 5 halves. 5 halves is 2.5, so I have to subtract a half to get to 2, which means that A is equal to negative 1/2. So the vector 2, 3, in terms of our standard basis, is equal to the vector negative 1/2 and 5 halves in terms of basis, we'll call it B. Now, the alternative way to do this is to create the transformation matrix. And the transformation matrix, T, that takes things from B and puts them into our standard basis, is given by the matrix with these as the columns. So 1, negative 1, and 1, 1. So if I took a vector V in terms of basis B, and I took my transformation matrix, this is some vector V in terms of basis B. This is going to give me some vector u in terms of the standard basis. Which means that if I have a vector in terms of the standard basis here, 2, 3, the inverse of this matrix is going to, if I left multiply both sides by it, is going to give me this vector VB. So if I find T inverse from B to standard, which is a half times 1, 1, negative 1, 1, this matrix will map things from standard into B. So if I take 1/2, 1, 1, negative 1, 1, and I multiply by 2, 3, I end up with the vector 2 minus 3 is minus 1, divided by 2 is minus 1/2, and then 2 plus 3 is 5/2. So this is the same result, obviously, as here. And it's this vector represented in terms of these two basis vectors. So if we want to look at this in a diagram, what we have here is our vector 2, 3, written in terms of our standard basis. The green and purple represent the alternative basis. And so you can see here that we're going negative 1/2 of the first basis vector, and then 1, 2.5 of the second basis vector. And it gets us to this point 2, 3, which is sort of right there, not at the tip of the arrow, right in the middle of the arrow. So these are the two methods. You've got the system of equations method, where you find your A and B by taking your vector and decomposing it into the new basis. Or you can form the transformation matrix, take the inverse of it, and multiply your original vector by that to get your new your vector in the new basis.